These are some topics you have to just do. An integer p that is greater than or equal to 2 is a prime if and only positive integers divisors are 1 and p. Euclid proved that there are infinitely many primes n that is equal to 1 plus in the product form of primes. The primary roles of primes in number theory is stated in the fundamental theory of arithmetic, which states that every integer n which is greater than or equal to 2 is either a prime or can be expressed as a product of primes. The prime number theorem describes the asymptotic distribution of the primes among positive integers. The theorem states that the random integers between 0 and some integer n, the probability that the integer is prime number is approximately 1 by log base e n. So this is the very important topic, and now at this stage we cannot going to discuss, because for this we have to understand the principles of mathematical induction, the combinatorics and the probability theory, and the more advanced knowledge of the prime numbers. These all are the advanced topic of prime number. This is important. Fermat's little theorem. If p is a prime, then the integer a to the power p minus a is multiple of p, like p divides a to the power p and gives the remainder a. So this is Fermat's little theorem and applicable for many problems, especially in the form of index and power, and we can solve by applying this concept. A to the power p is congruent to a mod p. It means that p divides a to the power p gives the remainder a.